Hello, now today we are going to be looking at the factor theorem. And the factor theorem says that if we have a factor x minus k, so one of our brackets when we'd be multiplying out our parts of our equation would be x minus k, could be x minus 3, x plus 5, something like that, then if that is a factor, we automatically know that x is equal to k is a root. So this is a very important tool that we need a lot when we are particularly working with cubic equations. So a lot of the work today is going to be with cubic equations, though what we find is valid for quadratic equations as well, but most of the time we're going to be dealing with cubics. Now, this is a little bit abstract. We're going to put it into practice immediately. So first question, is x minus 3 a factor of x cubed minus x squared minus 10x plus 12? So if x minus 3 is a factor, that means that x is equal to 3 must be a root. Now I'm going to show you how you do this in general because sometimes it won't be quite as straightforward as this. But something that if we hadn't been talking about the factor theorem, there's another way to do this question, and that would be to use long division to divide x minus 3 into our cubic expression, and we would see that we would get a remainder of 0 if x minus 3 was a factor. So we could do long division, is a method you already know. We do the long division, and we're going to practice long division in a few minutes. We could do long division and show that we would get a remainder of 0, 0 when we would do out that long division. Now there's a faster way to do this question using the factor theorem, so that's what I'm going to do to begin with, but we will be coming back to the fact that we know that if we divide a factor into our expression, into our equation, we are going to get a remainder of 0 if it is indeed a factor. So that is a valid method, full marks for doing it, but it's faster if we can spot that we can use the factor theorem. So that's what we're going to do for our first example. So we have x minus 3 is a factor. Now that means we can rearrange this x minus 3 equals 0. Effectively, where is that factor equal to 0? If we rearrange that, add 3 to both sides, we'd have therefore x is equal to 3 must be a root. So this is the key new piece of information as opposed to our long division that we already know. So let's check this. Now if this is a root, if x is equal to 3 is a root, what does that mean? Well, this is effectively an equation y is equal to this cubic. What happens for a root of an equation? It means where we're crossing the x-axis, so where y is equal to 0. So if we sub in x is equal to 3 into this equation, we should get y equals 0. So let's see if that's what happens. Always put in brackets when you're substituting. So we're putting a 3 in anywhere we have an x, and we're going to see if this works out to 0. So we have 27, we're checking whether this is equal to 0. 27 minus 9 minus 30 plus 12 is equal to 0. We put that into our calculators, and we will find that that is indeed 0 equals 0. So therefore x minus 3 is a factor, because we find that when we sub in x is equal to 3 into our equation, we get that our function equals 0. So that is how we can test if something is a factor much faster than having to do long division. Now another style of question that they could give you in the same vein would be if they gave you the cubic and a factor. So if we have x minus 4 as a factor, of x cubed minus 5x squared plus px plus 8. And we want to show and we want to find the value of p. So find p. Now in this case, we're going to use the fact that we know if we divide a factor into our function, we are going to get a remainder of 0. So this is going to be the long division that we practiced earlier on. We've practiced multiple times. Sorry. We've practiced multiple times. And we are going to do long division, and we're going to have a letter involved, which makes it look a little bit messier, but does not change the steps in the long division at all. Plus 8. Now remember, long division, divide, multiply, subtract, bring down. Dad, mother, sister, brother, if you prefer. Divide x into x cubed, we get x squared. Multiply x squared by x is x cubed. X squared by minus 4 is minus 4x squared. Subtract, so we are going to subtract. If we subtract a negative, it's the same as adding. So we end up with 0 here, minus 5x squared plus 4x squared is minus 1x squared. Final step, bring down, plus px. Repeat the cycle again. X divided into minus x squared is minus x. Minus x by x is minus x squared. Minus x by minus 4 is plus 4x. Subtract. Again, all of the steps that we are already familiar with in long division. Now this gets a little bit messy, so I'm going to write this out. So I have plus px minus 4x. Now, I want to have this clear for when I want to divide my remaining stuff here by x. So I'm going to take the common factor of x out here. So this is going to be p, this is a bracket, p minus 4 on x. I've just taken the common factor of x out. So I have p minus 4 multiplied by x. So now, and then bring down. So now I'm going to follow my steps again. It looks a little bit messy, but it's the same steps. X divided by, sorry, p minus 4 multiplied by x divided by x is going to leave me with plus p minus 4. And then multiply p minus 4x, and then p minus 4 multiplied by minus 4 is minus 4 on p minus 4. Following the same steps, just looks a little bit messier because we have algebra involved. Subtract. And we know, because we're told that x minus 4 is a factor, that these two must sum to 0, 0. So that means I now have an equation. I have 8 plus 4 on p minus 4 is equal to 0. And now I want to rearrange to find what p is. That's what I'm looking for in my question. So subtract 8 from both sides. I'm trying to isolate p. So I end up with 4p minus 16 is equal to minus 8. I don't want this 16 here, so add 16 to both sides. 4p is equal to 8. I want p by itself, so I want 1p, so 4 divided by 4 is 1. P is equal to 2. So I've been able to use my factor that I know that the factors must come to 0 in order to get my final answer. And then a final type of question that they will sometimes ask you is they'll just give you a cubic without any factors and want you to figure out what the factors are, and I'm going to write that out for you now. Now what we're looking for is find all the factors of this cubic equation here. Well, this would be an equation. So find all of the factors of my cubic equation, and I'm going to use substitution as my first method of this. So I know that if I find a root of this equation, where this equation equals to 0, if I find a value of x that makes this equal to 0, I found a root, and from that I can create a factor. That's what my factor theorem gives me. So if I can find a root of this equation, I'll have found one factor, and then I could use long division to fill in what I don't know. So what I'm going to do is try different values of x to see what is equal to 0. Now, for reasons we're not going to get into at the moment, you can narrow down your search to the factors of minus 20 divided by 1. So you're going to take the number that is in front of the cube and divide it into the number on the end, and that's going to give you all of the numbers you have to worry about in terms of factorizing. So minus 20. This is a similar type of narrowing down than we can use when factorizing quadratics. So what numbers are we looking for? Well, we'd be looking for plus or minus 1 by plus or minus 20, or we could be looking at plus or minus 2 by plus or minus 10, and so on. And usually you'll only have to go through plus or minus 1, plus or minus 2, plus or minus 4 to get your answer. So I'm going to do out a few of those and we'll have a look. Now all I've done is a bit of calculator work. I've said x could be equal to plus or minus 1, and I subbed in x is plus 1 into my equation, and I got minus 18, which isn't 0. X is equal to minus 1, gave me minus 12, which isn't 0. And then I tried x plus or minus 2, I tried x plus 2, and I found that that was equal to 0. So x is equal to 2 is a root of the equation because it makes the equation equal 0. Therefore, rearranging, get everything equal to 0, and I find that x minus 2 must be a factor. Now, what we're going to do now is use long division in order to narrow down our missing factors. So x cubed plus 5x squared minus 4x minus 20. And we're going to follow the same steps here again. So x squared divide in minus 2x squared minus plus 0 and 7x squared plus 7x squared, bring down and divide in. We have plus 7x plus 7x squared minus 14x, subtract, get 0 plus 10x, bring down, divide in x, and we get plus 10, multiply 10x minus 20, and lo and behold, when we subtract that, we get 0, 0, which is an extra check that we have done our maths correctly. We got a remainder of 0. That means that we've got our correct factor. X minus 2 is definitely a factor, and that means that if we have x minus 2 multiplied by x squared plus 7x plus 10, that is equal to our original cubic equation. Now we can factorize this quadratic in the way that we already know how to factorize quadratics. You've already done that lots. When you factorize that, you will get x plus 5 multiplied by x plus 2. By factorizing this quadratic, you get these two factors. You already know how to factorize a quadratic, and that is our job done. We have found all of the factors of our quadratic, of our cubic, I should say, equation. So those are the three different styles of questions that you often come across connected with the factor theorem, and also if you see cubic equations in general, it's a good idea to have these tools in the back of your mind.